Ever wondered how chemists count atoms, molecules, ions without pulling out a microscope? They use something called a mole. What is a mole? A mole is just a number. Like a dozen equals 12, a mole equals 6.022 times 10 raised to 23. That's Avogadro's number, and it's huge because atoms are tiny. Think of it like a bag of marbles. Instead of counting each marbles, you can say you have a bag of marbles. A mole is like a really big bag that holds specific number of atoms or molecules. It is 6.022 times 10 raised to 23 of them. Mathematically, the mole can be represented as, we say, mole is equal to mass over molar mass, which is also equal to number of particles over Avogadro's number. These particles could be protons, neutrons, atoms, or molecules. Now, let's look at the relationship between mole, molar mass, and Avogadro's number. How does these three terms relate? Think of it like this. Avogadro's number is like a special counting unit. A mole is the actual count, and the molar mass is the weight of that count. It's like saying a bag of rice weighs 5 kilograms. Where the bag is the mole, the rice grains are the Avogadro's number, and the 5 kilogram is the molar mass. They are all connected, and you can't have one without the other. So we say 1 mole of a substance is equal to the molar mass of that substance, and is also equal to 6.022 times 10 raised to 23 particles of that substance. So if you have 1 mole of carbon, that will be equal to 12 grams of carbon, and also equal to 6.022 times 10 raised to 23 atoms of carbon. What this means is that 1 mole of carbon contains 12 grams of carbon and 6.022 times 10 raised to 23 atoms of carbon. So if you have 2 mole of carbon, that will be equal to 24 grams of carbon, and also equal to 2 times 6 times 10 raised to power 23 atoms of carbon. Now, we are going to be taking some questions on mole concepts you are likely to see in your exams. Now, let's look at this question. It says, if 1 mole of ammonia contains Y number of particles, then how many particles do 1 mole of glucose contains? This is very easy. We know that 1 mole of any substance contains the same number of particles, which is 6.022 times 10 raised to 23. So if 1 mole of ammonia contains Y number of particles, then 1 mole of glucose would also contain Y number of particles. Since 1 mole of every substance contains the same number of particles. Now let's look at this. It says 1 mole of sucrose contains how many grams of sucrose? Now this is very easy. We know that 1 mole of any substance is equal to the molar mass of that substance. So in this case, 1 mole of sucrose will be equal to the molar mass of sucrose. So to answer this, we need to find the molar mass of sucrose. Now let's calculate the molar mass of sucrose. In sucrose, there are 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. Carbon has a molar mass of 12, hydrogen has a molar mass of 1, and oxygen have a molar mass of 16. Multiplying and adding this together, we have 342 grams. So the molar mass of sucrose is 342 grams. So we can say 1 mole of sucrose contains 342 grams of sucrose. Now, let's look at this question. It says, calculate the number of moles in 96 grams of oxygen atom. We know that the molar mass of oxygen is 16 grams, and this means that 1 mole of oxygen is equal to 16 grams. Here, We don't know the number of moles that's equal to 96 gram. So we say let that be equal to x. So we say let x moles of oxygen be equal to 96 gram of oxygen. Cross multiplying, we have 1 times 96, which is equal to x times 16. Making x the subject of the formula, we have x is equal to 96 over 16. Dividing this, we have 6. So there are 6 moles of oxygen in 96 gram of oxygen atom. Now let's look at this question. It says, how many moles are there in 20 gram of calcium carbonate? This is very easy. Here we are given the mass of calcium carbonate as 20 gram and the molar mass of calcium carbonate is 100 gram per mole. We know that mole is equal to mass over molar mass, so this will be equal to 20 over 100. Dividing this, we have 0.2 moles. So there are 0.2 moles in 20 gram of calcium carbonate. Now let's look at this. It says calculate the number of moles in 12.044 times 10 raised to 23 atoms of sodium. We know that 1 mole of any substance contains 6.022 times 10 raised to 23 particles. So 1 mole of sodium will be equal to 6.022 times 10 raised to 23. Since we don't know the number of moles in 12.044 times 10 raised to 23 atoms of sodium, we say let it be equal to x. So we say let x moles of sodium be equal to 12.044 times 10 raised to 23 atoms of sodium. Now we cross multiply. This would be 1 times 12.044 times 10 raised to 23 equal to x times 6.022 times 10 raised to 23. Making x subject of the formula, we have x is equal to 12.044 times 10 raised to 23 over 6.022 times 10 raised to 23. Dividing this, we have x equal to 2 moles. So there are 2 moles of sodium in 12.044 times 10 raised to 23 atoms of sodium. Now let's look at this. A sample of CO2 contains 3.01 times 10 raised to 23 molecules of CO2. If the molar mass of CO2 is 44 gram per mole, what is the mass of the sample? We know that mole is equal to mass over molar mass, which is also equal to number of particles over Avogadro's number. In this question, we are asked to find the mass. So we cross multiply, making mass the subject of the formula. So mass is equal to molar mass times number of particles over Avogadro's number. We are given the molar mass as 44 gram, the number of CO2 molecules as 3.01 times 10 raised to 23, and we know that the Avogadro's number is 6.022 times 10 raised to 23. So this would be 44 times 3.01 times 10 raised to 23 over 6.022 times 10 raised to 23. Multiplying and dividing this, we have the mass equal to 22 gram. So the mass of that sample is 22 gram. Try this. What is the mass of 0.25 mole of carbon dioxide? Drop your answer in the comment section and also don't forget to subscribe.